Hello everyone. Today, I'm going to show you an incredible trick. Transforming this simple, empty Coca-Cola bottle, often overlooked as trash, into a powerful and surprisingly effective tool. With the center mark, I'll use my drill to create a pilot hole exactly where I made my mark. This small hole will guide my larger drill bit and prevent the plastic from cracking. Next, I'm switching to a step drill bit. I'll carefully enlarge the hole in the bottle cap. I'm using a utility knife to gently refine the edges of the hole in the cap. I'm checking the fit with a battery to make sure it's just right. Moving on to our next component, an empty aluminum can. Next, I'll mark the very center of the can's bottom. With the center marked, I'm now drilling a small hole into the bottom of the aluminum can using my drill. This hole is essential for the later assembly, connecting different parts of our device. I'm taking an angle grinder with a sanding disc and carefully sanding the entire bottom surface of the aluminum can. This reveals the pure aluminum, which is important for conductivity and bonding. After sanding the bottom, I use a utility knife to smooth out the entire round base of the aluminum can. I needed a separate, clean metal plate for our setup. I will mark a smaller hole next to the center hole on this disc. I'm using a small wooden block underneath for stability while drilling. Using the drill again, I'm carefully making the new small holes at the point I just marked on the metal disc. I'm inserting small screws through this hole and securing them tightly with nut, creating robust contact points. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. I will take the red bottle cap and a valve. I'm inserting the valve through the center hole in the cap and securing it with a washer and nut. Now I take the prepared aluminum can bottom and slide it into the valve that is already attached to the lid, tightening it with pliers to hold it firmly in place. This forms our central contact for the heating element. I'm taking a length of red electrical wire and stripping a small section of insulation from one end. I'm twisting the exposed copper strands tightly to prepare them for connection. This wire will carry the current. I secured the stripped red wire end to the small nut on the cap and wound it tight. Tight connections are incredibly important for safety and efficiency. This setup creates the basic circuit that will ultimately power our heating element, drawing energy through these connections from the battery. The integrity of this wiring is fundamental to the device's performance. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. For the heating element, I need a carbon rod. I'm taking an old battery and carefully peeling off its outer casing with pliers. After completely removing the shell, I will use a box cutter to cleanly remove the plastic layer on the battery. I carefully remove the metal positive terminal cap from the top of the battery, then pliers to gently pull out the carbon rod. To ensure maximum efficiency and conductivity for our tip, I'll clean the exposed top of the carbon rod thoroughly with paper. To make our carbon rod tip precise and effective, I'm securing it into a drill chuck. Then, using sandpaper press against the spinning tip, I'm refining it. This sharp point will help concentrate the heat, making our soldering more precise. Once sharpened, I clean the tip with the paper while it's still spinning to remove any residue. With the outer shell of the battery, I am carefully using pliers to pry the shell off. Then I cut the zinc shell and put them into a wide plastic bottle. I'm pouring some liquid from this cleaning solution bottle into a plastic bottle. This liquid will react with our battery cases. Now, for our electrical connections. I'm stripping the insulation from one end of this red wire to expose the copper. I'm taking the red wire assembly we made earlier and attaching another crocodile clip to its free end. This will be the positive terminal, completing our primary electrical connection. I'm carefully inserting the sharpened carbon rod into the hole in the aluminum disc on the bottle cap assembly. This rod is our heating element. To ensure the carbon rod stays firmly in place and makes good electrical contact, I'm adding a little baking soda around the base where it meets the aluminum disc. This helps to seal the connection for optimal performance. Then I add super glue, which combined with baking soda. creates a super strong bond. To keep everything insulated and secure, I'm wrapping the bottle assembly tightly with red electrical tape. This prevents any accidental short circuits and provides a sturdy grip. It also gives our tool a cool, finished look. Now, I'm preparing the other end of our circuit. I'll take this blue wire, strip some insulation, and attach 2 clamps to it at different points. These clamps will connect to our power source and the object we want to heat, completing the electrical circuit. I'm connecting the crocodile clips from our red and blue wires to the terminals of a 12-volt battery. This battery will provide the power for our device. I have a small block of wood here that I use as a workbench. Let's see what it can do. See, when I touch the carbon rod with the alligator clip, it melts instantly, showing that it can work instantly. This is a small metal cup with a broken handle. This will be a test for our awesome new tool. I use scissors to carefully cut a razor blade into a small piece. This piece of metal helps in the soldering process, so that it does not get too hot and damage the cup. Now, let's attach the metal cup to the black clamp. When I touch the carbon rod from our device to the cup, notice how quickly the rod glows red hot. This shows the immense heat generated. You can see the heat transferring and working its magic. It's truly impressive how hot this simple setup can get. I'm scrubbing a metal mug with a wire brush. Look, it's holding the mug in place. This really shows the power of our homemade tool. Try it on something else, a razor blade. I'm carefully touching the sharpened carbon rod to the razor blade. See how it instantly glows red hot and starts to melt right through the metal? This homemade tool is quite powerful and incredibly effective for precision heat work. This shows that our device can work on a wide variety of materials. Our incredible multifunctional heating tool, made from a simple plastic bottle, an aluminum can, and a few clever additions. Thank you for watching, and I'll see you in the next one.